Hi there, welcome back to the video. In the last video, we implemented logic to check if the hero is standing on any platform. In this video, we extend the game object to define moving logic. We will begin by extending the game object with moving logic, and then we will make the hero to use the movable game object. We will also focus the hero at the center of the game screen whilst it is moving. Let's begin at the game es6.js file in the project. We create a new class named movable game object. It extends game object class. In the constructor, we take two parameters. The first one is graphic, which follows the game object's constructor. The second one is a world reference, which we will need to access the other game objects in the world. That's because the moving game object will interact with other game object. We call the super with the graphic reference. Then we use this.world to store the world reference. We also define a velocity object, which contains both x and y velocity. For testing purpose, we give them value 1. This is a movable object, so we need to have a loop to keep reflecting what's moving. In Create.js, we can create game loop by handling the tick event. The tick event is fired from the stage to all its children in the entire display list. We have set up the original one in-game class. You can find the line of code that is create.js.ticker.on. Open brackets, quotes, tick, quote, comma, this.stage, close bracket. It essentially tells the Create.js that we want to create a heartbeat for the stage container, which propagates the tick events to all the children. The reason that we have set up the tick for this stage is to re-render the stage 60 frames per second. According to the documentation, each time its tick method is called, it will render its display list to its target canvas. Inside the tick, we apply the x and y velocity to the game object. This code ensures that when we update the velocity value, the movement of the game object changes. Let's move on to the hero class. We now change the hero to extend movable game object instead of the original game object class. Let's move the world class. If we still have the testing code in the world class, we want to remove them at this moment. Now we want to modify the world position to focus on the running hero. When the hero runs from left to right, we don't want the hero's graphic to go outside the game screen. That's because the focus is that hero. We can move the world based on the hero's x velocity. It is a technique known as camera. In our game, we only need to follow the hero in x-axis, but if the game allows the hero to move in y-axis and beyond the game screen, the camera also needs to handle the y-axis too. When the subject moves in one direction, we move the entire container in the opposite direction. Let's see what happens if we don't follow the opposite direction of the hero. We can disable the falling of the hero by setting the y velocity to 0. Then we disable the world's moving code in the tick method. Save the file and refresh the browser. We can see the hero is moving towards the right and disappears at the game's boundary. Now, if we move the world, but in a different speed of the hero's velocity, let's say we move the world in a -2 value, refresh the browser, and now the whole world disappears because the camera is moving too fast. Now, if we set the world to follow the same velocity of the hero in positive value, refresh the browser, and we can see both the hero and the world is moving forward, and the world disappears after a short while. Let's revert back to our code and make the world move in a negative direction with the same speed of the hero's x velocity. Refresh the browser, and now the world moves backward while the avatar moves forward. It is like we have a camera focusing on the hero and tracing its movement. We have defined the hero as a movable game object. We also focused on the hero's movement at the center of the screen when it moves. In the next video, we will make the hero falls by adding gravity to the world.